In this lesson, we're going to continue working with the coordinate plane and we're going to talk about the length of line segments. So we have two learning goals for today. We're going to find the length of a horizontal and vertical line segment on the coordinate plane, and we're going to solve real-world problems involving coordinates and a coordinate plane. So let's start with this first example. We are going to find the length of each line segment on the x and y axis. So I have four line segments here. On the y-axis, I have line segment HG. I also have F, which is located at 1, all the way down to E, which is down at -8. I have AB, which goes from -4 to 2. And then I have CD, which goes from 3 to 7. So to find the length of each line segment, all you have to do is find the distance. Okay, and distance is always a positive number, right? You don't drive somewhere and go negative miles. The same on the coordinate plane. We're not going to go from 3 to 7 and go -4 units. So you can look and you can know, okay, if I start at 3 and I have to end at 7, how many units did I go? Or the easiest way is, let me take yellow, is to count the boxes. You're going to start at 3 and you're going to go 1, 2, 3, 4 units. So CD is 4 units. Let's look at AB. Here's A at -4, and B is all the way here at +2. So look at the number line. I go from -4 to 0. What's that distance? And then plus another 2. So again, you can count. Go 1, 2, 3, 4, 5, 6 units. AB is 6. I went from -4 to 0, that's 4 away, and then plus 2 more is 6. Now let's try HG, which is up here on the y-axis. I go from 5 down to 2, or you could do it the other way, and I go from 2 up to 5. Now a common mistake is students go like this. Ready? 1, 2, 3, 4. You don't include the first number, right? We're counting the distance. So it's from this number to the next number. That's 1. Then another one. Then another one. This line segment is 3 units. Now let me erase this yellow so we can see. We are going to do the last one, which was F to E. But you can do E to F. It doesn't matter. It will still be the same distance. So let's go bottoms up. So I go from -8 to 0 plus 1 more. Can you take a guess as to what that distance is? 1, 2, 3, 4, 5, 6, 7, 8, 9. FE is 9 units. Let's take a look at another example. For this one, we're going to write the coordinates of each point and then find the length of the line segment. So on this example, I already have the coordinates for MN and RS. So we're going to start with M, which is up here at you start at the origin, remember, to write a coordinate. You go -5, jump up to +5. N is -5, jump up to 1. So the X coordinates are the same. Let's figure out the length of the line segment. Let's count. 1, 2, 3, 4. Right? Because from 1 to 5, I go 4 units. Now let's do RS, which is over here. Do you remember what quadrant this is? Quadrant 1. Okay, so all of the coordinates are positive. So R is crawl 2, up 2. And S is crawl 6, up 2. Here, the Y coordinates are the same. So let's find the length of RS. 1, 2, 3, 4. This one is also 4. And if you look at the coordinates, look, from 6 to 2 or from 2 to 6, I have a difference of 4. And the last one, PQ. So let's write the coordinates for P. P is over here in the third quadrant, and we crawled -3, jump down to -10. So -3 goes first, And then the y is, negative 10. Now Q is in quadrant 4 over here, and we crawl to 6, jump down to negative 10. So 6, negative 10. So again, my y coordinate is the same here. So I'm going from negative 3 to 6. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's a distance of 9 units. The next example, I have a shape on a coordinate plane. I have a rectangular garden. Okay. Now I put this caution here. The caution says, remember to look at the scale of the graph before finding the coordinates of a point or before finding the length. This coordinate plane is different. Look at my x-axis. It doesn't go by ones anymore. It goes 2, 4, 6, 8. So even though we're moving one box, I'm really going a length of 2. And the same for the y-axis. That's super important. You always want to just, before you start any problem, just double check how are my axes labeled. So in this one, it goes by 2. So it says find the length of each side. Okay, so we're going to take this rectangle and find the length. Let's do AB first. So again, look, I'm going one box, 2 boxes, 3, 4, 5. But did I really go a distance of 5? No. I went 2, 4, 6, 8, 10. AB is 10 units, which means what's the length of DC? Also 10. Now let's do AD. AD is, again, you could count the boxes, but just be careful because it goes by 2. So we're going to count by 2. 2, 4, 6, 8, 10, 12, 14, 16. So this length is 16 units, which means BC is also 16 units. Now part B says, what's the area of the rectangle? Well, do you remember the area formula for a rectangle? Base times height. So we're going to take our base times our height, which means our area is, our base is 16 times 10. And what is 16 times 10? 160 units. The next slide is a continuation of the problem. It wants to say, or it's asking, what is the perimeter? So actually, let's go back and we'll just find the perimeter here. If area is base times height, perimeter is when we add up all the sides. So to find the perimeter, so I'm going to just actually do that over here instead of the next slide. I'm going to add 16 plus 16 plus 10 plus 10. So I know that 10 plus 10 is 20, plus 16 plus 16 is 32. And what is, 32 plus 20 is 52 units is the perimeter. And then the last question for this rectangular garden is, a palm tree is planted at point E. So point E is not on my graph, which means I'm going to have to plot it. So a palm tree is pointed at plant E, and it's a distance of 12 meters from AB and 4 meters from AD. What are the coordinates of point E? Okay, so let's think about this. It has to be 12 meters from AB. Here's AB. So it has to be 12 meters away. Should I count 12 boxes? No, remember it goes by 2. So if I count 2 by 2s to get to 12. 2, 4, 6, 8, 10, 12. So it's going to be somewhere over here. And it needs to be 4 meters away from AD. So AD is up top. I need to be 4 meters away from it. So 1, 2. So my answer is going to be somewhere around here. Now, if I have to be 4 meters down from AD and 12 meters from AB, that means that point E has to be right here. Okay? And then they want the coordinates of that point. Okay, remember it goes by 2, so it's over to 14, up to 8. Okay, so I had to be 12 meters away, so you're going to count 12 away. And then, so you knew you were going to be somewhere on this line. And then you have to be 4 meters down from AD. So you kind of have to draw 2 lines and figure out where they meet. And then write the coordinate, 14, 8. And then we could even label this E, or you could draw a palm tree. The next example, write the coordinates of points A, B, and C. So here I have a triangle on the coordinate plane in quadrant 1. So let's write our coordinates for A. A is, aha, take a look at this. What do you notice? Do my units go by 1? No. Both the X and Y axis are labeled by 5s. So even though I go up 1 box, I'm really going 5. So when I do point A, I crawl to 10, but then I jump up to 20. What about point B? I crawl to 10 and I go up 1 box, right? If I put 10, 1, is that correct? No, I went up 1 box, but it's really 5 units up. And then point C, I crawl to 30 and I jump up to 20. Okay. Next question. Miss Felice wants to build a fence around this garden. If BC is 25 meters, so B to C, this length here, is 25. How many meters of fencing does she need? Okay, well, if I'm putting a fence around it, that's perimeter. I'm going to add up all the sides. So let's find the length of A to C. Remember, I'm going by 5s. 5, 10, 15, 20. So this is 20. Now let's do the length of AB by 5s. 5, 10, 15. So now Miss Felice wants to build a fence. So she needs to add up all, she needs to add 20 plus the 15 plus the 25, which they gave us. So what's 25 plus 15? That's 40. Plus 20 more is 60 meters of fence. Oops, of fence. Oh, and that is my last question. So now I would like you to do the practice that is then assigned after this video. Good luck!